Okay guys, this is lesson 14 and what we're going to be doing today is working with radicals again, which is square roots. Okay, so if you look at example 1, these first ones are radical equations. You have an equal sign and so you are solving. So here are the steps right here. First thing you need to do is get the radical alone. And don't get confused, the radical just means the root. Okay, so get it alone. And then the second step is to raise it to a certain power to get rid of the radical, and then to solve it and to check. The only time you're required to check is if you raise both sides to an even power. But I think it's important to check anyway because you want to get this right on the midterm. Okay, so let's start with example 1. Step 1 is to get that root alone, that radical alone. So all you're going to do is just move the 3 over. So you have the square root of x, the square root of 2x minus 1 is equal to 3. Now, the opposite of add is subtract, the opposite of multiply is divide, the opposite of square rooting something is squaring it. So you know how this little number right there is a 2? That tells you that I have to square both sides. And then what happens is this square right here and this square root actually undo each other. So you end up with 2x minus 1 is equal to 3 squared, which is 9. Move the 1 over, you get 2x equals 10, divide by 2, and you get x equals 5. Okay, now we're not done. And the reason we're not done is because we even powered both sides. So sometimes when you even power both sides, it makes it turn weird and the answer is really not a solution. So what I want you to do is I want you to write the word check, and you always go into the original problem, and wherever you see an X, you put in the solution we just got, which is 5. So it looks like that. Now, see the right-hand side, how it's a 0? Just leave that be and work with the left-hand side. So inside of that radical, 2 times 5 is 10. 10 minus 1 is 9. So you really have the square root of 9 minus 3. The square root of 9 is a 3. 3 minus 3 is a 0. I got 0 equals 0, so it checks out fine. Guys, you would never add a plus or minus in front of that 9 because you didn't take the square root. The square root was there to begin with. So if there's no plus or minus at the beginning when you write the root down, then you don't write the plus or minus, okay? So your answer is 5 and you're done. And the awesome thing is, because we plugged it back in and it worked out, we know we're right for sure, okay? Okay, let's go with question B. Well, first of all, I don't even have a radical, but I can very quickly write it as a radical. See that little number's a 3, so that's what goes inside of there. This is x over 2 plus 1. This 1 right here means this is raised to the first, but that's not going to change anything, so I'm actually not even going to write that down. It's not necessary, okay? And then we have equals negative 2. So when I look at that negative 2, it makes me concerned, but I know it's probably going to be okay because this is an odd. So if that's an odd root and it's equal to a negative, then you're good. If that was an even equal to a negative, then that's a problem because an even root is never going to be a negative number. Okay, so to get rid of the cube root, I'm going to cube both sides and I'm going to put parentheses around those. So on the left, the cube and the cube root undo each other. So you have x over 2 plus 1 equals, and negative 2 to the third is a negative 2 times a negative 2 times a negative 2, which is a negative 8. Move your 1 over, so you have x over 2 equals negative 9. Now I'm just going to add a 1 and cross multiply. 1 times x is x equals negative 9 times 2 is a negative 18. Since I did not even power, I odd powered, I'm not required to check my answer, and I'm done. Okay, that was part B. Here is part C. So step 1 is to get the radical alone. You guys, if you see this right, then you're going to be able to do it correctly. So see that thing I just highlighted? Imagine that like being a Y. So if you had y over 2 plus 3 equals 4, that works exactly the same way. So if this were your problem, the first step would be to just move that 3 over, and that's exactly what I'm going to do. So then I have the fifth root of 3 minus 2x over 2 is equal to 1. And then I have to get rid of the 2. So one way you could think about it is to cross multiply. That's what I think is the easiest. So if you cross multiply, you get the fifth root of 3 minus 2x is equal to, multiply the other way, 1 times 2 is 2. Okay, I'm just going to leave it at that. Now I need to get rid of that fifth root, so I'm going to raise to the fifth power. I don't have to put parentheses around the 2 on the right-hand side because it's not a negative. If I did put parentheses around it, it would be fine, but it's not necessary. Okay. On the left-hand side, the fifth root and the fifth power undo each other. So it's 3 minus 2x is equal to 2 to the fifth, which is a 32. Bring your 3 over and it becomes a negative. So I have a negative 2x equals a positive 29. Divide by negative 2, and I get negative 29 over 2. And again, I don't have to check this because I odd powered and not evened. Okay? If you wanted to check it, you could, but you don't have to. Okay? Question D, we're actually going to throw that thing out and we're not going to do it at all. And now we're here on question E. Okay, so question E is a little different. You have more than one root. So if you have more than one root, the first thing you want to do is split them apart. So this would be the square root of 2x plus 6. Move the other root to the other side. This negative becomes a positive sign. These signs inside don't change. It's just the outside sign. So it's a positive, and it's a square root of x plus 4. Now, they're both inside a root, even root, square root actually. So to get rid of it, I just square both sides. So then I have 2x plus 6 equals x plus 4. This plus 1x comes over and becomes a minus 1x. 2x minus 1x is 1x plus 6 equals 4. Move my 6 over and it becomes a negative, and I get x equals negative 2. Now this one I am required to check because I even powered both sides. Remember, when you check, you always check from the original, okay? So everybody go the square root of 2 times negative 2 plus 6 minus the square root of negative 2 plus 4 is equal to 0. Okay, now I'm going to show you a shortcut. So grab your calculator. And all we're going to do, you guys, is just put the left-hand side of what I've just written down in my calculator. So everybody just hit second x squared, 2 parenthesis, negative 2, close the parenthesis, plus 6. Now, this is just a little bit confusing, but if you look at the calculator, as soon as you hit second x squared, the calculator automatically inputted a parenthesis right there. And so what I have to do now that I've got the 6 is I have to close that parenthesis that the calculator started. And what I'm saying is I'm now done putting the things inside of the root. Let's do it again. So go minus, and then everybody hit second x squared. Do you see how a parenthesis automatically pops up from the computer? So the computer, or the calculator, I mean, put a parenthesis right there. So then we just go negative 2 plus 4, and now I have to tell the calculator that I'm done with that radical, so I'm going to close it, hit enter, and I got a 0. Okay, so this totally checks out. My answer's good. X equals 2. You know, the beautiful thing is, first of all, I was supposed to check it, and I did. But the other thing is, I know I'm right. Like, there's no way that answer is wrong unless I plugged it into my calculator on the check wrong. So anyway, that's it. Okay, here's question F. So those are cubed roots. So to get rid of them, I'm going to cube both sides. So the cube and the cube roots go away. So I have 2x minus 4 is equal to 3x plus 8. This plus 3x comes over and becomes a negative. So you get negative x minus 4 is equal to 8. The 4 comes over and becomes a positive, so you have negative x equals 12. Change the signs, x equals negative 12. Now, I'm not required to check my answer, but I want to practice checking. So let's just check this one, just so we can practice putting this in the calculator. So everybody go, the cube root of 2 times negative 12 minus 4 equals the cube root of 3 times negative 12 plus 8. Okay, let's put the left-hand side in. So everybody go 3, second, and then go down 4 buttons to the caret button, which looks like that. And then go parenthesis, and then I'm going to go 2 parenthesis, negative 12, close it, minus 4. Now I have to close my radical, hit enter, and I get negative 3.037. Let's see if I get the same thing on the other side. So everybody go 3, second, hit that caret button, 3 parenthesis, negative, oops, sorry, do that again, clear that out. Everybody go 3, second, caret button, then go parenthesis, 3 parenthesis, negative 12, close it, plus 8, close my radical, hit enter, and I got the same thing, negative 3.037. So it totally checks out. I didn't have to do that. I just feel like we need to practice with this calculator a little bit, okay? So that's it. Okay, this guy right here, you guys, I look at question G, and I can see right now that the answer is going to be no solution. The reason that I know it's no solution is because a root, an even root, can never ever be a negative number unless you had a negative sitting out right there to begin with. Because if you think about it like this, just for a second, like say you had 25, negative 25. So the square root of negative 25 is a 5i, and the square root of 25 is a 5. Neither one of those has a negative sign. You can't get a negative sign unless there's a negative out there to begin with, okay? Well, let's say we didn't know that. So we square both sides, write this with me. So on the left, the square and the square root go away. On the right, you have to add parentheses. The whole thing is squared. So a negative 5 squared is 25. Move your 1 over. 4x equals 26. Divide by 4, you get 26 over 4, which is 13 over 2. Now, since I even powered it, I'm going to check. So everybody go the square root of 4 times 13 over 2 minus 1 equals negative 5. Okay, I know this is not going to check out. There's no way it's going to work because this can't be negative unless I have a negative sitting right there. Okay, but let's do it. Everybody hit second x squared. Notice the calculator put a parenthesis already, so go 4 parenthesis, 13 divide 2, close it off, minus 1, close your radical, hit enter, and I get 5 equals negative 5, which is not true. So I'm going to say 5 is not equal to negative 5, therefore my answer is no solution. Okay, you literally didn't have to write any of that if you could see from the beginning. And if I did that, if I didn't do any work at all, I would just write something like this: a square root cannot equal a negative number. I would offer some kind of explanation as to how I got it. Okay? Okay, question H. We have 2 roots, so I'm going to get those on opposite sides. So I'm going to take this guy and pull him that way. So I have 5 times the square root of 2x equals. Remember, when I pull him to the right, these signs are not going to change. The only sign that's changing is that one. It's a negative, so I pull it over and it becomes a positive, like that. Now, this is kind of awkward because you've got that 5 sitting there, and now you have to get rid of the root, so you have to square. That's okay. Just square it like this. Okay, you guys, the 5 is not added to the square root of 2x. If it was, you would have to write 5 plus the square root of 2x times 5 plus the square root of 2x, and you would have to FOIL that. But it's much easier than that because it's not added. So all you have to do is square the 5. 5 squared is 25. The square root of 2x squared is the square root of 2x times the square root of 2x, which is 2x. And then on the right, the squared and the square root go away, so you have 3x plus 1. So now I have 50x equals 3x plus 1. Move my 3x over, so I have 47x equals 1. Divide, and I get x equals 1 over 47. It looks kind of scary and kind of bad, but it's fine because I have a calculator. I do have to check it. The reason I have to check it is because I even powered both sides. So remember, when you check, you always check from the very beginning equation right there. Okay? So everybody go 5 times the square root of 2 times 1 over 47 minus the square root of 3 times 1 over 47 plus 1 equals 0. The right-hand side is so clean, guys. It's just a 0. Just write it down and don't move anything around. Just evaluate the left-hand side. Okay, here we go. Everybody go 5 second x squared. Notice the calculator automatically puts a parenthesis in there when it's square root. Then I'm going to go 2 parenthesis, 1 divide 47. Now you have to close off your 47, and you also have to close off the radical. So that's 2 closes right there. Then go minus second x squared. Notice it puts an automatic parenthesis right there. So I'm going to go 3 parenthesis, 1 divide 47, close it, plus 1. Now close my radical. Hit enter, and I got 0. So I ended up with 0 equals 0. It totally checks out. There's my answer, and I'm done. Okay? That was question H. Here is number 2. Why is there no solution? Once again, we have an even root with no negative sitting in front equaling a negative number. I'm just going to say A, not N, I'm going to say A square root cannot equal a negative number, comma, unless there is a negative in front of the square root. That's it. Okay? Does this have a real number solution? I can tell that the answer is no. Because again, I have a root with no negative sitting in front equaling a root that does have a negative in front. I can't do it. Okay? Does it have a real number solution? No. Okay, and then it says explain. I'm going to say the same thing that I have up here. I'm going to say a square root cannot equal a negative. And you guys, this really is a negative number. If you look at the square root of 5, the square root of 5 is 2.2. That's just a negative number. So a square root cannot equal a negative unless there is a negative in front of the square root. That's all I'm going to say. Okay? Example 4. A student tries to solve this by squaring both sides, and they get this. Why is that not correct? Okay, well, let's do it correctly. So when they ask you, is this equal to this, or is this correct, the best thing you can do is to do it correctly. okay? So your square roots are separated. I've got to square this side, and I also have to square this side. So the square root and square root go undo each other, so you have 2x plus 5, so that was right. You guys, this is a binomial. So you would have to write the square root of x plus 4 times the square root of x plus 4. Those are not conjugates. You don't just multiply the f's and the l together. So what this person did, square root of x times the square root of x is x. 4 times 4 is 16. That would be great if they were conjugates, but they're not. So that is not how you do it. You have to FOIL this whole thing. So guys, look, square root of x times the square root of x is x. Outside is the square root of x times 4. That is 4 square root of x. Inside, 4 times the square root of x. That's 4 square root of x. Last is 4 times 4, which is 16. Okay? Why is that not correct? I would say, let me see it this way. When you square both sides, comma, the right side is a binomial. Then I would say you must FOIL the right-hand side. Okay, that's it. That is it. Okay, so I think the toughest part about this lesson might be the calculator work, knowing how to check it. Please don't fake that. Some people are like, oh, I'm just going to put 0 equals 0. I'm not going to put it in my calculator because it's too complex to put in. You don't want to do that. You know, I want to say one more thing. When I'm checking this guy right here, okay, yes, it's a little difficult to put in that left-hand side. So I want to show you one more thing. Everybody grab your calculator. And what I'm going to do is I'm going to take this -2 and I'm going to store it in as x. I believe we've done this together. So everybody go -2, hit the store button. So it's on the left side, second from the bottom, and then hit enter. And now when I do this, guys, instead of putting in this -2 and this -2, I can just recall the value of a. So do this with me. Everybody go second x squared. And then it's supposed to be 2x plus 6. So I'm going to go 2a plus 6. So go 2, mem bar's on the left, third button up, hit enter, and then go plus 6. Do you see how you have to close that radical? Look at your calculator screen. Do the next one, minus second x squared. The calculator gives you the parenthesis. Then go mem bar, enter, plus 4, close it, enter, and there's your 0. So probably easier to store it and then check it that way. But just when you do that, make sure that you write down what you did. But when you do it, when you put it in your calculator, it can actually store in the -2. Okay? Okay, that's it, you guys.